Welcome student. In today's lecture we will see about the various types of pump. Okay, so here we are starting from the screw pump. So what is the screw pump? The screw pump, it is a fixed displacement pump, consists of the two Archimedes screw that intermesh and encloses with the same chamber. These pumps are used for the high flow relative at low pressure. They are used on the board ships where a constant pressure hydraulic system extended through the whole ship, especially to control the ball walls, but also to help drive the steering gear and other system. Okay. This pump has one inlet at each end. Here you can see. Here we can see this pump has a one inlet at the end and the outlet at the middle. Okay. While running, liquid fills into the gap between the screw and the casing, moving it along with the screw from inlet to the outlet. So the inlet, and you can see at the ends it is having the inlet of the screw, and at the middle it is have the outlet. The liquid coming through this way is comes between the gap between the casing and the screw, and it starts moving in the forward direction as the rotation of the screw, and it moves to this central outlet here. Okay, the screw is run with the help of the prime mover. Some advantages are it's simple, less number of parts, then it is having low cost and quiet in operation, and has high operating speed. Okay, now this is the unbalanced vane pump. You all are very familiar with this unbalanced vane pump. It is having inlet at one end and outlet is exactly opposite. It is having this rotor block is run with the help of this motor, and on this rotor it is having a slot on which the vanes are mounted. These vanes are flexible one in both size moves, both goes out and come inside the slots here, and the space between this rotor and this casing is used to compress the oil here or to increase its pressure here. It consists of a cylindrical rotor which is mounted with the offset inside a circular casing. The vanes are sealed at the radial slot of the rotor and held against the casing by spring force or hydraulic force. Hence there will be any leakage of oil between the vane tips and the casing, but still there is some leakage. As the rotor rotates, the size of pocket goes on increasing on left side and reducing on right side. This causes suction of oil at left side and delivery of oil at right side. Difference in pressure between the inlet and outlet ports create a side thrust on the rotor shaft. Here we will see some of its animation. Here is the animation of this with pump. So this is the vane pump. It is having the rotor and having the slots on which this vane is mounted. You can see this black are the vanes. This vane moves out and again comes in the vane, and it traps the liquid between the casing and the space here. This is the rotor mechanism. These vanes are moving out and in. So this is the inlet. And on the next hand there is presence of outlet there. Okay. So this is the unbalanced vane pump. Actually, there is no balance provided. There is the because of this thrust get produced. This is the variable displacement vane pump. The only difference it does, there is the provision of this screw, and by using this screw we can vary the discharge here. That's why we name it as variable displacement vane pump. Rest is same. Only there is a provision of the screw here. This is the balance vane pump. This is a balance vane pump because there are two inlets and two outlets are employed here in balance vane pump. Due to this, the equal and opposite side thrust are balanced, and hence this type of pump gives the better service and longer life. Here you can see it is having the two outlet and two inlets. That's why the thrust is get balanced, and we call this pump as a balance vane pump. Now this is the straight axis piston pump. Okay, so what is this straight axis piston pump? Here you can see it consists of a cylinder block. You can see it consists of the cylinder block and the axial bores here. These are the bores, and the axis of this cylinder and piston and cylinder bores is coincident. Pistons are inserted in the bores, and the other hand the piston is connected to the shoe plates with the shoe joints. Here you can see this is the shoe plate and the swash. Some may call it a swash plate or shoe plate. The shoe plate is mounted on the which is fixed at an angle to the axis of rotation. The angle of swash plate can be varied to change the displacement. When the shaft is rotated, here this is connected with the shaft. When the shaft is rotated, it causes the cylinder block rotates, as the shoe plates will be also rotates, which is causing the piston to reciprocate in the pores. Half rotation of cylinder block causes suction of oil, and the next half rotation causes the discharge. Here what is happening, due to the rotation of this swash plate and the shoe plate, there is the reciprocating motion of this piston is caused inside the cylinder pore. Here I will show you. So this is the straight axis piston pump. The cylindrical bores, you can see it's a cylinder bores, and these are the pistons connected with the shoe plate and the swash plate, which is connected to the root. Okay. This is a drive shaft. The swash plate connected with the shoe plate. This is the piston which gets reciprocating motion inside the cylinder block or cylinder bore. Okay, this is the outline. This swash plate is at some angle. Okay, so this is the working of this straight axis piston pump. The first half here. Here you can see this is straight axis piston pump. Here this piston gets the reciprocating motion because of the rotation of the swash plate. Here you can see the swash plate. You can see here this piston gets the reciprocating motion inside the cylindrical bore. You can see here, as this swash plate is rotating, the piston moves in and out of this cylindrical bore. The outward motion of this piston is suction, and inward motion is the delivery stroke of that particular cylinder there. Okay. Now the another type is the bent axis. The only difference between the straight axis and bent axis is that in bent axis the axis of this shaft which is rotating the swash plate is at some angle to the cylindrical bore. Here you can see. There are the extra parts actually. This is bent axis because the axis of this cylinder block and this shaft which is rotating the swash plate is at some angle. This is the bent axis piston pump. Else the working is same. This piston is moving in and out of the cylinder, causes to suction and forcing out the fluid. Here again the axial piston pump are positive displacement pump which converts the rotary motion of the input shaft into the axial reciprocating motion of the piston. This bent axis piston pump motor using the bent axis principle, fixed or adjustable displacement. It exists to a different basic design. The Thoma principle which maximum 25-degree angle, and the Balmack principle with spherical shaped piston in one piece with the piston rod, piston ring and the maximum 40-degree between the driver shaft, center line and piston. These have the best efficiency of all pump, although it generally the large displacement are approximately 1 liter per revolution. The radial piston plunger pump, you already are familiar with this radial piston displacement pump. On the center, the working piston extended in radial direction symmetrically around the drive shaft, and it contracts to the axial piston pump. When half having the suction, other half having the delivery stroke, and when when particular one having the suction, then other have the delivery. The stress bent axle, stationary cylinder, radial piston. Okay students, so we are stopping here. Now we are going to see some numericals of this pumps. I will teach you in the next section. Thank you.